Hello, my name is Tete Jacob Richie and welcome to my online tutorials. Our discussion on numerical and computational methods will be on numerical differentiations. So if, let's say, a function y is equal to x cubed plus 2x and we are asked to find the value of dy over dx at the point 2, we can easily do that. That's y is equal to x cubed plus 2x. Then we can say our dy over dx will be equal to 3x squared plus 2. So at the point 2, we substitute 2 in place of x at dy over dx. We say 2 squared plus 2. 3 times 2 squared plus 2. 2 squared is 4 plus 2. 3 times 4 is 12 plus 2, and that becomes 40. That's if the function is known. What of if the function is not known? Rather, the values that the function produces is what is given to us. How do we find the first derivative, the second derivative, and perhaps the third derivative of the function that produces those values at a given point? That is known as the numerical differentiation. So before the video ends, I will take you through how numerical differentiation comes about, and we'll take a sample question and try to find solution to it. It will be a very interesting engagement, so please come along. So if you remember very well, we said this formula here, or this expression, is from Gregory Newton's forward difference interpolation formula. Please check out my videos on how these formulas came about by watching my videos on Gregory Newton forward difference and backward difference interpolation formula on YouTube. So we can rewrite this as y naught equal to yn equal to y naught plus n delta y naught, then plus, 2 factorial is 2, so I can rewrite that as half delta square y naught. That's, I brought this first. Then times, I'll multiply this by this, I'll get n squared minus n. Then plus 3 factorial is also 6, so I'll write 1 over 6 delta cube y naught. Then bracket, I'll expand this, and if I expand this, I'll get n cube minus 3n squared, then plus 2n, then plus in order. Also, if you watch that video very well, we said the n is giving us x minus x naught all over h. So we have two functions. That's y equal to y naught plus n delta y naught, then plus half delta this and that. And we want to find dy over dx from this. We need to use chain rule. Remember, this n can also be written as x over h minus x naught all over h. All this, the x naught and the h are constants. So, to find dy over dx, or the first derivative, it will be equal to, from chain rule, it will be equal to dn over dx. That's the differential of this function with respect to x. Then times our dy over dn. That's the differential of this function with respect to n. So when we do that, you see that the dn will divide the dn, then we have our dy over dx back. That's the function of the chain rule. So what do? We need to differentiate this function with respect to n, differentiate with this function with respect to x, then we substitute to find our first derivative. So since our n is equal to x over h minus x naught over h, we can find our dn over dx from this. So when we differentiate this function, we'll get 1 over h. Since this is constant, the differential of that will be 0. Now let's differentiate this with respect to n. That's dy over dn. This will be equal to, since this is constant, it will be 0. This is linear, so the differential of that will just be delta y naught. That's the constant. Then We differentiate this, we get plus half delta square y naught times, when we differentiate this, we get 2n, then minus 1. Then plus 1 over 6 delta cube y naught. Then we differentiate this, we get 3n squared minus 6n, then plus 2, then plus in that order. I hope you get that. So we can say that our dy over dx, remember, we said is dn over dx times dy over dn from chain rule. Then our dy over dx will be the dn over dx, which is 1 over h bracket delta y naught plus half delta square y naught times 2n minus 1, then plus 1/6 delta cube y naught, then times 3n squared minus 6n plus 2, then plus in that order. I hope you get that. So this will be our first derivative. Now, how do we find the second and perhaps the third derivative? So having known our first derivative, we can find the second derivative. So the second derivative, that's d square y over dx squared will be equal to 1 all over h squared bracket. Now we differentiate this function now again. Remember, this is constant. When we differentiate, it will be 0. We have half delta square y naught. Then we differentiate this, we get 2. Then plus 1 over 6 delta cube y naught. These are all constant. So we differentiate this again, we get 6n minus 6, then plus in that order. We can repolish this function. We can have 1 over h square bracket. If these two multiply this half, we'll get 1. So we'll have delta square y naught, then plus 1 out of 6. Since there is 6 common here, I can factor it out. So I'll get 6 out. Delta cube y naught to be left with n minus 1, then plus in the order. So finally we have our d square y over dx squared to be equal to 1 over h squared delta square y naught plus, so this will give us 1, have delta cube y naught times n minus 1 plus in the order. I hope you get that. So now we'll find a third derivative from this function. So our third derivative, that's d cube y over ds cube will be equal to 1 over h cube bracket. So this is constant. I won't differentiate it to be 0. Then this will have delta cube y naught. When we differentiate this, we'll get 1. So when we multiply by it, it's still that. Then plus in that order. I hope you get that. Now, how do we get these values? Delta y naught, delta square y naught. We can get that from the construction of our difference table that produce, or the function that produces that difference table. When we construct a difference table, we get those values from it. So now we'll take some sample questions and see how you can find the first, second, and the derivative of a function at a given point. So we are going to solve our first example on this. But before we do that, please remember to subscribe to my YouTube channel. This will make my YouTube channel grow more and I can share more mathematical content for you. Please don't forget to like and comment. Your comment keep me going. So the question says that we should find the first, second, and the third derivative of the function f of x at x is equal to 1.5 if the table of values of x and f of x are given in the table below. So the values of x are 1.5 up to 4.0 and their corresponding f of x are also given. So the first thing we need to do is to construct a different table if we need this. So we just let y should be equal to our f of x. Then we construct a difference table as this. So we list the x values here. F of x values become y, so we list them, leaving space to them to write the differences for the y. So the difference between 7.00 and 3.7375 is 3.625. The difference between 3.625, that's 13.625 minus 7 will give us 6.625. Then 24 minus 13.625 will give us 10.375. 38.875 minus 24 will give us 14.875. And 59 minus 38.875 will give us 10.125. We go further to find the second difference. That's 6.625 minus 3.625 will give us 3. 10.375 minus 6.625 will give us 3.75. Then 14.875 minus 10.375 will give us 4.5. And 10.125 minus 14.875 will give us 5.25. Since this did not produce the same values, we go further to find the third difference. That's 3.75 minus 3 will give us 0.75. Then 4.5 minus 3.75 will give us 0.75. Then 5.25 minus 4.5 will also give us 0.75. So having gotten all of these values being the same, that means the polynomial function that connects the x to y, or the form of the f of x, is to the third power. I hope you get that. Please do well to check out my videos on how to construct difference table and how to determine the form of a polynomial function that connects two values on YouTube. Having known that, then the next thing is to go to your Gregory-Newton forward difference interpolation formula. So, using Gregory-Newton forward interpolation formula, we are going to use these values, where this is our y0, this become our delta y0, delta square y0, and delta cube y0. So, remember we said n is giving us x minus x0 all over h, which we can rewrite as x over h minus x0 all over h. So, how do we find dy over dx from this? Remember, we said that we'll find dy over dx from this function. Then we'll find dn over dx from this function. Then we multiply the two. That becomes our dy over dx using the chain rule. So, from the first one, our dy over dn will be equal to the differential of this function. This is constant. One differentiate is 0. One differentiate this, we'll get delta y0. One differentiate this, we'll get half delta square y0 times 2n minus 1. Then one differentiate this, we'll get 1 over 6 delta cube y0. Then the differential of this will be 3n squared minus 6n. There is n here, so then plus 2. I hope you get that. I quote it up to the third difference because our function is up to the third difference. Now I'll find my dn over dx from this. Remember, these are constant. One differentiate this, you get 1 over h. The differential of this is 0 since it's constant. Then remember, we say our dy over dx will be equal to dn over dx times our dy over dn. That's the product of these two derivatives. What happens? Dn will divide the dn, then we have our dy over dx back. So our dy over dx will be equal to dn over dx is 1 over h. So 1 over h bracket. Our dy over dn is delta y0 plus half delta square y0 then times 2n minus 1 plus 1 over 6 delta cube y0 then times 3n squared minus 6n then plus 2. So having known our first derivative, the question says we should find the value of that. That's the first, second, and third. So we should find the value of the first derivative at the point x is equal to 1.5. So we'll use x is equal to 1.5 to find our value of n. So at s equal to 1.5, then our n will be equal to 1.5 minus, what's our x naught? Our x naught, remember we said if it is Grigori-Newton forward difference, then it is the first value of x, which is also 1.5. And the h is the difference between these x values. That's 1.5. The difference between 1.5 and 2.5. You see that all is 0.5. So we can say our h is also equal to 0.5. So our n will be equal to 1.5 minus x naught, which is also 1.5, over the h, which is 0.5. 1.5 minus 1.5 will be 0. Over 0.5 is still 0. So we know that our n is 0, our h is 0.5. We substitute into this. Then remember our delta y naught, delta square y naught are all in this value. Where this is delta y naught, this is delta square y naught, and this is delta cube y naught. We just substitute to get the first value of the value of dy over dx. So we can say our dy over dx is equal to 1 over h, and h is 0.5 bracket. Our delta y naught is 3.625. So 3.625, then plus half. Delta square y naught is 3, so times 3. Then 2, our n is 0, so times 0 minus 1. Then plus 1 over 6. Delta cube y naught, our delta cube y naught is 0.75. So times 0.75. Then we substitute n equal to 0 here. So we get 3 times 0 squared, which is still 0. So 0. Then 6 times 0 is still 0. Then plus 2. I hope you get it. When we polish further, we get 1 over 0.5 bracket 3.625 plus 3 over 2 times 2 times 0 is 0, times this will be minus 1, then plus 1 over 6 times 0.75, 3 times 0 is 0, minus 0, then times our 2. I hope you get that. So when we simplify further, we'll get 1 divided by 0.5 is 2, so times our 3.625. Then 3 over 2 times negative 1 will be negative 1.5. 1 over 6 times 0.75 times 2 will give us 0.25. 3.625 minus 1.5 plus 0.25 will give us 2.375 times our 2 will give us 4.75. Then we can say that our dy over dx will be equal to 4.75 at s is equal to 1.5. I hope you get that. So we have found the value of our first derivative. We can go further to find the value of the second derivative at the point s is equal to 1.5. So we can find our second derivative. Remember we said it to be d square y over dx square and to be equal to 1 over h square and times the differential of this function. Remember this is constant, one differentiate to be 0. Then we have half delta square y naught. On differentiate this we get 2. Then plus 1 over 6 delta cube y naught. The differential of this will give us 6n minus 6. Remember 6 is common, we can factor it out to multiply this. So we get 1 over h square, 2 times half will be 1, so we get delta square y naught, then plus 1 over 6, we can factor our 6 out to get delta cube y naught, then n minus 1. So on polish further, we'll get 1 over h square bracket, delta square y naught, plus delta cube y naught times n minus 1. being our second derivative. So we find the value of this second derivative at the point s is equal to 1.5. So at s is equal to 1.5, we find our n. Our n will be equal to 1.5 minus our x naught. Remember, it's also 1.5. Then over the h. Remember, we said the h is 0.5. This will also give us the 0 over 0.5, and that's still 0. So we know our n to be 0, and remember the h is 0.5. We just substitute. So we can say our delta square y over our d square y over dx square will be equal to 1 over h is 0.5, so 0.5 square, then bracket our delta square y naught. Remember, from the difference table is 3, and delta cube y naught is 0.75. So we say 3 then plus 0.75 times our n is 0, so we say 0 minus 1. So on polish further, we'll get 1 over 0.5 square with 0.25 bracket 3, then 0 minus 1 will be negative 1. Negative 1 times 0.75 will be minus 0.75. So our 1 divided by 0.25 will be 4. Then 3 minus 0.75 will be 2.25. Then when 4 multiplied 2.25, we get 9.00. So we can say that our d square y over dx square will be equal to 9.00 at s is equal to 1.5. I hope you get that. So we'll go further to find the third derivative, the value of that at the point s is equal to 1.5. So having known our second derivative, we can find the third one. We can say d cube y over dx cube will be equal to 1 over h cube times, remember this is constant, I want to differentiate it to be 0. Then when we differentiate this, we'll get delta cube y naught. N minus 1, I want to differentiate that is 1. Times that will still be delta cube y naught. So at x is equal to 1.5, remember our h is 0.5. We substitute again. So we get 1 over 0.5 cube, then times our delta cube y naught, remember, is 0.75. So we just pick it from the table. So 0.75. So we can get 1 over our 0.5 cube will give us 0.125, then times 0.75. 1 divided by 0.125 is 8, then times 0.75. Then 8 times 0.75, that will give us 6.00. So we can say that our d cube y over ds cube is equal to 6.00 at s is equal to 1.5. I hope you get that. So this is all about a numerical differentiation. Please remember to subscribe to my YouTube channel before you sign on. Hit that like button and comment, because your comments keep me going. Until we meet again on numerical analysis, my name is Kepsi.